Hey there, I'm Jonas. Welcome back to my channel. Today we're going to implement stack using queues. So let's have a quick recap about what is stack and what is queue. So the stack is a LIFO data structure, which means last in, first out. Say we have a data set from 1 to 3, and we will append them into the stack. We will append the element from the right to left and follow the sequence. We'll have 1, 2, and 3. So if we want to pop out an element, which element should be the first one to be out? So follow the behavior of the stack, which is LIFO. We will have the last element that has been appended will be the first one to be out. So the 3 will be the first one to be out, and then the 2 and the 1. So what about the behavior of the queue? So basically the queue is the analog of what people doing in the daily life, right? So people are lining up to wait for a service or a food, and the first one in the line will be the first one to be served. So that's called the FIFO, first in, first out behavior. For appending, we will append from the right to left, and we will have the same sequence as the stack, 1, 2, and 3. So if we want to pop out an element, follow the FIFO behavior, the first one come into the line will be the first one to be served. So element 1 is the first one in the line, so it will be the first one to out, and then the 2 and the 3. So basically queue have two ends. One is for appending and another one is for removing. So how are we gonna do to use queues to implement the same behavior of the stack? We will use two queues to do that. So basically, we will implement several basic functions of the stack in the myStack class. For stack, we have the push to append element into the stack, and the pop will remove the first element on top of the stack, and the top will be like to pick the top element, and empty will check if the stack is empty. So basically, we want to deal with the sequence of the removal and the append. Let's look back to this illustration. If we want to achieve the behavior like a stack to have the same LIFO behavior, how about flip the second queue a little bit like the one below? So basically, this part is similar to the behavior of the stack, right? So how are we going to do this? Say we want to append the first element, which is 1, to the first queue, and it will be at the front of the queue. So basically, if we just have one element, we can simply to use the 0 index to get the first element to achieve the top and the pop function. And we can basically check if the queue is empty to implement the empty function in the myStack class. If we want to push more elements, we just need to append it into the queue. So the push and the empty are the functions can be implemented easily. For pop and top, if we want to append more elements, then the pop and top will be different. Say we want to append the second element, which is 2, to the queue. So if we directly append the 2 into the first queue, the first element of the queue will still be the 1. So if we call the pop or top, we will not achieve the element that we expected. So how about append 2 directly to the second queue instead of appending to the first one? So in this way, we will append 2 to the front of the second queue. Then it's at the front of the second queue, and if we call the top and the pop, we will have the correct element, which is 2. Then to maintain the expected sequence, we will append every element at the first queue to the second one. Then 1 will be behind the second element 2. The second queue is basically the expected queue or the expected sequence we want to have in the stack, because we want to make our code to be easy, that we don't want to to check the first queue and the second queue and to determine whether the first element is in the first one or the second one. So we want to keep all the elements into the first queue. But now all the elements are in the second queue, right? So how are we going to do to like give them the correct label? So we can swap these two queues, and it's just like flip these two queues. So basically we will just like to assign the number 1 to the second queue and the number 2 to the first queue. We will see how we do this in the code. So basically we will just like move the second queue on the top and the first queue to the bottom. And then if we want to append more elements, say we want to append the third element, which is 3, we will append directly to the second queue as what we did in the first one. So the 3 will be the first element of the second queue. And if we call the pop or top, the 3 will be pop up. And then we will append all the elements in the first queue to the second one. So first we will pop out the 2 and append the 2 into the second queue, and pop out the first element 1 and append it into the second queue. Then the second queue in the bottom will be the expected sequence for the stack to pop out. Then we'll do the same thing, that flip the whole queues and keep all the elements in the first queue. So that's basically how we solve this problem. Since we pop out every element and added them into the second queue, we will have the time complexity of O(n). Okay, so let's code it up. Before we implement this myStack, I want to mention that we will use the queue library to implement the queues. And we will not use the dequeue. The dequeue has some advanced features, and in this problem, we can just use some basic queue operations to implement the stack. So first, I want to mention that there are some basic operations for the queue, and let's see how we instantiate a queue object. So we will name a variable called queue, and queue is going to be queue.queue. And basically, we will have the append and the pop out and check empty operations for the queue. So first, say x is a variable that can be an integer or a float or an object. So the put will be append the x element into the queue, and the get function will pop out the first element of the queue. And queue.empty will check if this queue is empty. Just a quick recap of what we have for the queue. So remember in the drawing, we mentioned that we will have 2 queues to implement this stack, right? So we will have 2 queues. All right. So for the push, remember that we will push the new element directly into the second queue. And then we will pop out every element in the first queue and append them into the second queue. So we will check if the first queue is empty. If it's empty, we will know that we have pop out every element in the first queue, right? If it's not empty, we will first pop out every element in the first queue and appended them into the second queue. And then the most important step is to flip these 2 queues. Basically, we will just swap the label of these 2 queues. then we'll finish the push function. And for the pop, as we have every element in the first queue, so we will just stay and focus on the first queue, and we will just pop out the first element of the queue, the first queue. And for the top, basically the same thing, but we will not pop it out, but just check the first element at the front of the queue. We can just basically use the 0 index to pick this element. Since we have every element in the first queue, we will just check if the first queue is empty. Okay, so we solved this problem and it beats 100% users.